very good morning, students. Today we can continue our topic of physics, that is system of particles and rotational motion. Yesterday we have learned the equation of rotational motion. The three equations you have learned, that is, first of all, omega is equal to omega 0, okay, plus alpha into t, okay, v is equal to u plus at. Second, theta is equal to as s is equal to ut plus half at square. So u replaced by omega 0 into t plus 1 half alpha into t square. And third equation, v square is equal to u square plus 2 times as, that is equal to, means omega square is equal to omega 0 square plus 2 times alpha into theta. So these are the three equations that we have learned. We have solved the numericals also on that equation. Today we are going to learn very important point, how to find out the moment of inertia of any body about any axis. About any body about any axis means what, sir? Means suppose if you know the moment of inertia of a body about any one axis, then you are able to find out the moment of inertia of a body about any given axis. Okay, one axis you know, then other axis you will be able to find out that things. But sir, how we can do that things? How we can find out the moment of inertia? For that, you should know the two important principles, two important theorems. And that two theorems today I am going to explain to you. The first theorem is, that is principle of parallel axis theorem. Okay. Sir, what is exactly principle of parallel axis theorem? Suppose for example, if this is any rigid body. Okay. In that rigid body, if suppose I want the moment of inertia, to find out the moment of inertia about any given axis, suppose that is I0. But I know the moment of inertia of a body which is passing through its center of mass, so that is supposed to be IC, that I know. And if the perpendicular distance between the two axes is supposed to be h, okay, so the principle of parallel axis theorem states that the moment of inertia of any body about given axis is the, means IO is equal to IC plus m into h square. Means what is that exactly that theorem? Moment of inertia of a body about a given axis is equal to the moment of inertia of a body about its parallel axis which is passing through its center of mass, and that is the sum of moment of inertia of a body passing through its center of mass and the product of mass of the body, total mass of the body, and square of the perpendicular distance between these two axes. Do you understand what I have explained to you? In short, what I have explained to you, moment of inertia of any body about a given axis is the sum of moment of inertia of a body about an axis which is passing, parallel axis which is passing through the center of mass, and the product of total mass of the body and square of the perpendicular distance between these two axes. So that is the principle of parallel axis there. Okay. So here any times moment of inertia about the given axis, means suppose I want to find out I0 is always greater than IC, because how much it will be greater? By the term of m into h square. With that term, that moment of inertia of a body about given axis will be always greater. You remember that things first of all. If now this is the moment of inertia about a given axis, then sir, what is its radius of gyration? Okay, and how we can find out that radius of gyration? So it's a very simple. So I know radius, moment of inertia in terms of radius of gyration, I is equal to m into k square, where m is the mass of the body, k is radius of gyration. So therefore the above equation can also be written as m into ko square is equal to m into kc square plus m into h square. I can write down by using this formula. So here k is the moment radius of gyration about given axis, k Kc is the radius of gyration passing through the center of mass, and h is the perpendicular distance between that two axes. So if I take m common and if I cut that this m, so then your equation will become k0 square is equal to kc square plus h square. Or we can also say that ko is equal to under root of kc square plus h square. So this is the radius of gyration about any axis. We are able to find out by using this term. Next point, if suppose I want to find out the radius of gyration about the center of mass, so that can be calculated by using the formula k0 square minus h square. Or if that will be kc square, then kc is equal to under root of ko square minus h square. So that is the another formula. Or if I want to find out the perpendicular distance, then the formula will becomes h square is equal to ko square minus kc square, or h is equal to under root of ko square minus kc square. So that is the another formula. So there are the three formulas are there to find out the radius of gyration about the given axis, or about the center of mass, that means axis which is passing through center of mass, or how to find out the perpendicular distance. So all these formulas have been given here. Okay, so this is all about the principle of parallel axis theorem. Once you got the idea about principle of parallel axis theorem, then there is another theorem is also there, and the name of that theorem is principle of perpendicular axis theorem. Okay, so sir, what is that? Principle of perpendicular axis, principle of perpendicular, okay, perpendicular, okay, axis, principle of perpendicular axis theorem. So now here I have to change that theorem now, that I will explain to you how we are able to find out moment of inertia. So particularly this theorem, if you want to find out for any thin lamina means having a very small thickness, and suppose means any body, any lamina which having a very high, that means thin thickness. So for that I can use this principle of perpendicular axis theorem. So the principle of perpendicular axis theorem states that, okay, so now here there are the two, that means axis. So IZ, this is the IX, and suppose this is IY. Okay, they are perpendicular to each other. So sir, means sir, how that exactly that theorem is? Okay, so here suppose I want to find out the moment of inertia of axis which is perpendicular to the plane lamina. Suppose this is the plane lamina and this is the axis which is perpendicular to the plane. So you see here, these are the three axes. This is supposed to be z axis, this is supposed to be x axis, this is supposed to be y axis. Or if you can take x axis, y axis, z axis, anything you can take it, but they should be perpendicular to each other. So suppose this is the IZ, if I will calculate, this is Ix or Iy, then moment of inertia of that plane lamina about that z axis is the sum of moment of inertia of two perpendicular axes which are lies inside that plane and intersecting at the point where that perpendicular axis cuts to that lamina. So that is the your principle of perpendicular axis theorem. Okay, so that means I will say like this: Iz is equal to Ix plus Iy. Again I will define what is that perpendicular axis theorem. Moment of inertia of the plane lamina about an axis perpendicular to its plane, okay, is the sum of moment of inertias of two mutually perpendicular axes which are intersecting at the point where the perpendicular axis cuts to that plane lamina. So that is Iz is equal to Ix plus Iy. So here in that case you remember Iz is always greater than Ix or Iz is always greater than Iy. So this will be always true. Okay. So now once you got that thing, so sir, what will be the radius of gyration for that case? So I can write down here as for calculating the radius of gyration, what I will do, Iz can be written as m into kz square is equal to m into kx square plus m into ky square. Okay, so this is the mk square z square is equal to mkx square plus mky square. So now here in that case here m will be common, then kz square can be written as kx square plus ky square. Okay, so that will be the formula, or kz is equal to under root of kx square plus ky square. So this is the first formula for calculating the radius of gyration about the z axis. If I want to find out the radius of gyration about the x axis, kx square can be written as kz square minus ky square, or kx is equal to under root of kz square minus ky square. So this is the another formula. Okay. Or third formula, if I want to find out about the ky square, so ky square can be written as kz square minus kx square, or ky can be written as under root of kz square minus kx square. So these are the three formulas for calculating the radius of gyration. Okay, about the this axis, x axis, y axis, or z axis. Okay, so if you know the moment of inertia about the two axes, we are able to find out the moment of inertia about the third axis. So that is the your principle of your perpendicular axis theorem. Now by using these two theorem, you are able to find out the moment of inertia of the different bodies. For example, if I want to find out the moment of inertia of a ring or disc, or you can consider thin rod, metal rod, or you can consider a disc, for that your cylinder, hollow cylinder, solid cylinder, or that is solid sphere or hollow sphere, we are able to do by using these two theorems. Okay, so now we can proceed one by one, okay, for each theorem. So the first theorem, that means that both the theorems we can use for the body which is supposed to be considered to be a ring. Okay, or instead of ring, I will take first of all thin rod. Okay, if suppose you have a thin rod, okay, so for the thin rod only, just I will explain to you what will be the moment of inertia. So moment of inertia of thin rod, but about which axis you are talking about? If I want to find out the axis which is passing through its center and perpendicular to its length, what will be its moment of inertia? So the first case for thin rod, for thin uniform rod, okay, thin uniform rod, find out the moment of inertia for thin uniform rod. Okay, so now suppose this is the thin uniform rod, okay, this is rod, and I want to find out the moment of inertia about this axis. So your formula is IC is equal to ml square by 12, where m is the mass of the rod and l is the total length of the rod. And if I want to find out radius of gyration, so that will be under root of IC upon m, and so that will be ml square by 12, and so therefore that answer will be will get cancelled, L upon square root of 12, or L upon 2 root 3, because 4 3s are 12. So that will be the radius of gyration about that passing through its center. Okay, so the next time we can see the moment of inertia about the different points, about its one end passing through its midway between the one end and the center of mass. Okay, today we'll stop here.